Parent functions are the simplest form of a graph, and later we're going to be transforming those functions and manipulating them. So the basic type of functions are going to be listed on the left. Notice this greatest integer function that may be relatively new. That just means it's the greatest number less than the number that's provided. For example, if your x is 0.03, the greatest integer less than that would be 0. If it was 0.2, it would be 0. 0.5, 0, 0.999, 0. As soon as it goes up to 1, then your f of x is going to jump up to 1. And so that's why it's called a step function as well. I have a picture of each of these graphs, and as you can see, the basic ones are shown on the left. And what I'd like to do is talk about characteristics of some of these graphs. For example, I'd like to look at the cubic and reciprocal function. And so what I'm going to do is write down the domain range of the cubic function. So the cubic function is, when you think about the domain, you're thinking about all of the x's that are covered by this. So you're going to see that it's going to go from a negative infinity to a positive infinity. Those are all of the x's that are going to be covered. The range, all the y's that are covered, and that's going to be the same exact thing. Intercepts. Intercepts are going to be both x and y intercepts. In this graph, there's only one which covers both of them, and that's going to be the point 0, 0. Symmetry, is it symmetric about the vertical line or the horizontal line, or is it symmetric about the origin? And it would be symmetric about the origin, because for each xy, it's going to have a negative x, negative y. Continuity, do you have to lift up your pencil? And so, yes, it is continuous over the whole thing. End behavior, that's left end behavior and right end behavior. So as you go to the left, as x's become smaller, you are going to have the limit as x goes to negative infinity of your f of x, and that answer is going to be a negative infinity. And if you were to look at the same exact thing going to the right, it would be the limit as x goes to positive infinity of f of x, and that is going to be positive infinity, because in this graph you're going to see that this is your f of x is going to go to a positive infinity. Is it increasing? Where's the slope positive? The slope is positive throughout the whole thing except for at that particular point 0, 0 where it flattens out. So we're going to say that it is going to be increasing from negative infinity to 0, and then it's going to be an union from 0 to a positive infinity. Decreasing does not exist. Is it odd? That means does f of negative x equal f of x? Negative. So does f of negative x equal negative f of x? If you were to put a negative sign in for a negative x in for x, you would see that this does hold. So we know that yes, it is. And the even, if you plug f of negative x in, you're going to see that that does not equal f of x. That's based on the definition that we've been given before. Reciprocal function. So we're going to go ahead and erase that and talk about the reciprocal function. So the reciprocal function is going to be where the domain are going to be all x's that are covered. Domain is going to be including all of your x's except for where x equals 0. How do you write it? You're going to write it as negative infinity to 0 and 0 to infinity. The range, looking at all the y's that are covered, it's exactly the same thing, but with the y's in mind. And the intercepts, there are no intercepts. Symmetry, is it symmetric about the x-axis, the y-axis? That answer is no, but the origin is yes, it is. Continuity, there is a discontinuity. So is it continuous? Does it have complete continuity? The answer is no. And behavior, the limit as x goes to negative infinity of f of x, when I go to the left, where is it approaching? It is approaching your y equals 0, or your f of x is equal to 0. And similarly, your limit as x goes to a positive infinity of f of x is going to be equal to 0 on the right side. Is it increasing or decreasing? Does it go up to the right? No, there is no increasing points in the graph. Does it decrease? Yes, it is decreasing. All of this has a negative slope, and therefore you're going to have from negative infinity to 0, and then again union from 0 to a positive infinity. Is it odd? Yes, it is. Is it even? No, it's not, because of the definition. Certain characteristics of the parent functions and diagrams of the functions. And you can see again, just to summarize the last two, we have absolute value, which is a V form, and the greatest integer function looks like a stepping function.